Today I want to discuss about types of reactions. In that, the first one is addition reaction, second one is elimination reaction, third one substitution reaction, fourth one rearrangement reaction. So one of the example here mentioned is ammonium cyanate. It is not cyanide. This is called cyanate. And on heating, this is a heat symbol. This will be converted into urea. This is a urea formula. Now, in that first year, you may be studied the addition reaction and elimination reaction little bit, but also we'll discuss completely in second year. Now, I am focusing on which one? Substitution reaction. After substitution reaction, we'll discuss about the elimination reaction. So now, substitution reaction, meaning what is that? Atom or group replaced by another atom or group is called substitution reaction. Substitution reaction, another name is called displacement reaction. Now, these substitution reactions are one is free radical substitution reaction, second one electrophilic substitution reaction, third one nucleophilic substitution reaction. Now we are focusing on this nucleophilic substitution reaction. Free radical substitution reaction little bit you studied in the alkane chapter, halogenation of methane or alkane, like this you studied. Electrophilic substitution reaction you studied in the benzene chapter. There what you call Friedel-Crafts alkylation reaction, acylation reaction, nitration reaction, all are electrophilic substitution reaction. Now our focus on this nucleophilic substitution reaction. So now first one is SN1 reaction. So what is the substitution meaning here? Substitution nucleophilic unimolecular reaction. Otherwise, this also pronounced as one mean unimolecular, N mean nucleophilic substitution reaction. Forward mean this is backward also, forward also we can write substitution nucleophilic unimolecular reaction. Here another one SN2, this can be written like this SN2 or down to, but generally this is a preferable representation. Substitution nucleophilic bimolecular, substitution nucleophilic bimolecular, or reverse we can read, that is called bimolecular nucleophilic substitution reaction. Anyway, that is the correct one. So now what is this one example here? The reaction between methyl chloride and hydroxide ion to yield methanol and chloride ion in single step, which follows second order kinetics. Now observe here what is happening. In this is a methyl chloride. This is a nucleophile OH minus. This will be attacked to this one and this will be leave. Therefore, we will get methanol. What is its name? Methanol, and this is a chloride ion is a leaving group. Lg mean leaving group. Now, same that reaction mentioned in the form of a complete structure. This is a nucleophile attack on this carbon, then leaving group leave. So which leaves from the substrate, that is called leaving group, which attack to the electron deficient side, that is called nucleophile. What is this? Nucleophile. Now where electron deficient, this one is called electrophilic carbon. Now nucleophile attack to this substrate, this is called RDS. RDS meaning what is that? Rate determining step. In this reaction, this nucleophile attack, this is a dotted, actually this dotted line, this is not completely attacked to this carbon, and this leaving group not completely departed from the this carbon, and this is a normal line, this is away and this is near to the observer. Now, according to this, we have three bonds only we have to consider. These are not complete bond. Therefore, this is called a sp2 hybridized carbon. Which one this is? Three bonds are present. Mean this is which one? Sp2 hybridized, and this is called a transition state unstable, cannot be isolated form. This is not as a intermediate. This is very fraction of section existing part. This is very high energy state. High energy states are very unstable. Therefore, immediately this will be converted into this one. So now here we have to consider total this OCl place which is attack here OH. This is attack from the back side, and remaining how many are there? Total three. So one is normal line, this is, and this is dotted line. This is a front carbon with the dark line. So this is called methanol, inverted structure. But we cannot say here R configuration mean S configuration, because here all hydrogens are same are there. RS configuration not applicable. Therefore, I want to tell this is just inverted, but not a inverted configuration like R mean yes, yes mean R. Like this not happened here. So this is called a umbrella type structure. This is, then this is, I will represent like this. So this is backside attack. Keep in mind here what is there, these groups are like this side is the left side, now right side shifted. This is, keep in mind. According to that, a incoming nucleophile OH minus interact with the alkyl halide, causing a carbon halide bond to break and form a new carbon nucleophile bond here, which is taken nucleophile OH. That's why I wrote here OH bond form. These two processes takes place simultaneously in a single step through transition state, and intermediate is not formed actually here. This here formed road, that is intermediate not formed here. Through a intermediate is not formed, only transition state is possible. Now, in rate determining step, both alkyl halide and nucleophile participated. That is called rate is directly proportional to alkyl halide and nucleophile. Both are involved in this. Therefore, rate depends on the concentration of alkyl halide and nucleophile. When proportionality removed means constant K alkyl halide nucleophile. Then power how much is there here? 1. Actually not -1. This is 1, and here this is 1, because sometimes student may not see properly. This 1 is, they may consider like this minus, but this 1, this is 1. Therefore, keep in mind n is equal to what is the sum of the powers of concentration power. Therefore, 1 plus 1, this is a second order. So here represent clearly, but here little mistake is there. Consider 1 plus 1 how much? 2. Second order kinetics. In RDS, it means rate determining step. Alkyl halide and nucleophile both participated. Therefore, it is a bimolecular reaction. Molecularity meaning what is there? Here molecularity of this reaction is 2. In a rate determining step, how many molecules simultaneously collide, that is called its molecularity. Two molecules are participating, therefore its molecularity 2. And now this is rate is equal to alkyl halide. In case nucleophile is in excess, excess is there mean what you call, that is zero order. Therefore, we can write it is in case, not compulsory always. Keep in mind if condition, if excess word is mentioned, therefore that time with respect to that, generally which one excess possible? Solvent. Therefore, if water is a solvent is there, that time first, it means second order reaction may also convert to first order if the solvent is a excess. Keep in mind stereochemistry of the SN2 reaction. causing carbon halide bond to break. In SN2 reaction, optically active halide are accompanied by inversion configuration. In case that carbon bonded with the four different group, 1, 2, 3, 4, all are different is there. Therefore, this is chiral. And for example, this is here given S configuration. Then here you will get R configuration. Then keep in mind R configuration, S or S configuration going to R means that is called Walden inversion. In board level, they may ask what is the Walden inversion or inversion configuration. So a optically active halide in SN2 reaction, nucleophile attack from the backside, then its configuration will be changed. So here optically active, then product form also optically active when nucleophile attack from the backside attack. Then same here, this is called like this dotted line. This is a dotted line. This is which one? This type of wedge dash type this is. Therefore, keep in mind this is a transition state. What is the hybridization I told in the previous sp2? Because these bonds are considered remaining dotted line bond. These are horizontal, not considered. So important for competitive exam, what is the hybridization of this transition state carbon in SN2 reaction? Very important, that is sp2 hybridized carbon. So now S configuration convert to which one? R configuration. So there is inversion configuration. Now in SN2 reaction, reactivity of alkyl halide. So now tertiary alkyl halides are totally least reactive, or maybe we can consider do not react because nucleophile attack at the where free space is available. That's why keep in mind tertiary being totally unreactive also consider no problem, or least reactive. This is least reactive part. Least reactive or do not react. Secondary alkyl halide react for SN2 reaction, but preferably primary better. Methyl alkyl halide is mostly or highly reactive. So keep in mind methyl primary, secondary are preferred to the SN2 reaction, but tertiary totally not preferred. Now, this is a energy profile diagram. Energy will be increases, reaction progress or reaction coordinate. This is a reactant nucleophile. When attacked, then it transition from this is dotted line like this dotted line. So this is a transition state, very unstable this is. Then this will be converted into product, inverted product this is. So keep in mind when nucleophile attack from the backside, then this will be converted into a umbrella type this is. Therefore you will get inverted structure. Now we'll discuss about which one SN1 reaction. First, what I completed now SN2 reaction. What is required for board level? That part maximum completed. And whatever the extra thing required, we discuss later. Now SN1 reaction we'll discuss. SN1 reaction. It can be represented like this. Actually, SN1 are like this. This is the most preferable. So, in this reaction, substitution nucleophilic unimolecular reaction, for example, the reaction between tertiary butyl bromide and hydroxide ion to yield a tertiary butyl alcohol and bromide ion in two steps, which follows the first order kinetics. Now, this is called a tertiary butyl bromide common name. Then IUPAC name. This is 1, 2, 3. 2 bromo alphabetical order first B first then methyl 2 bromo and this is a methyl 2 methyl propane. This is gives this is called 1 2 3. Therefore tertiary butyl alcohol common name, second position methyl, therefore 2 methyl propane 2 ol. Keep in mind. Then its mechanism. What is the mechanism? It occurs in two steps. The first step, formation of a stable carbocation. Keep in mind this word stressing here, stable carbocation. That's why here box I mentioned. Rate is directly proportional to the stability of carbocation. That's why stable carbocation only we want. Then I given here stability of the carbocation. So according to the stability of carbocation, this is benzyl carbocation is more stable than allyl carbocation, then tertiary, secondary, primary, methyl carbocation least reactive, that's why least involved in the SN1 reaction or does not interact in the SN1 reaction also considered. So most preferable which one benzyl allyl tertiary. So these are the most favorable react carbocation form in the SN1 reaction. So the rate of reaction depends upon the stability of carbocations. Now, the first one is step one, two-step mechanism. Therefore, the leaving group leave from the substrate. This is a slow step or also called rate determining step. Then what is formed here is carbocation formed. This is called tertiary carbocation. This tertiary carbocation is what is a hybridization 3 bond, therefore sp2 hybridization, or I will write here sp2 hybridizer. Now tertiary carbocation somewhat stable because of three methyl groups are there, plus I effect also is there, and hyperconjugation also is, due to this it is stabilized. Next, the polar carbon and bromine bond. This carbon bromine bond breaking for which energy obtained by solvation of proton of polar solvent, that is called polar protic solvent. Which type of solvents are required here? Water, this polar protic solvent, all alcohol, acetic acid, etc. So keep in mind, polar protic solvent means the solvent which gives the proton, they are called polar protic solvent. Step 2. The formed carbocation attacked by nucleophile and complete the reaction. So this carbocation when having one vacant p orbital, equal size lobes is there, mean that is uh, p orbital. If like this is mentioned, mean that is called hybrid orbital. Hybrid orbital lobe, one is small, one is big will be there. Equal size is there, mean that is called empty p orbital. This is now this is perpendicular to the plane. So this is a triangular meaning. This is a perpendicular, horizontal, perpendicular, or front and back type also consider. Therefore, if it is front part, then it's a back part. Mean nucleophile attack from the front side or from the back side. So here I mentioned this is called pure vacant p orbital. This is then two products are formed here. In case front side attack means OH front side, another forgot maybe here. Then this is a OH, this is CH3, CH3, CH3. Then two products are formed, one front side attack of OH, another is back side attack of OH. 2 methyl propane 2-ol. This is called tertiary butyl alcohol. So keep in mind, these are not racemic mixture. Generally, student will think this is a racemic mixture. Racemic mixture when it is possible, when they are chiral carbon. This is just normal. Therefore, I may be told that time in the classroom because this is identical is there mean one time only we have to represent, not two time. That's why we cannot write this is a racemic mixture. Chiral carbon not there here. Kinetics of this reaction. Rate of reaction depends on concentration of alkyl halide only reason. In the first step, what is participated here? Alkyl halide only participated in the rate determining step. In this rate determining step, only alkyl halide participated. Therefore, rate of reaction directly proportional to alkyl halide. Proportionality removed mean K constant. Alkyl halide here power how much is it? 1. Therefore, order of reaction is 1. This is called first order kinetics. In rate determining step, only one molecule, that is alkyl halide, that is tertiary butyl bromide involved. Therefore, molecularity is what is that? 1. Molecularity mean already I told you that in rate determining step how many molecule participate, that is only its molecularity. Therefore, one. This is why it is called unimolecular reaction. Now, stereochemistry. In SN2 reaction, stereochemistry, what is that? Generally inverted product form. In case chiral carbon is there, so R mean yes form, yes mean R will be formed. Now, in this case, in case of SN1 optically active chiral alkyl halide accompanied by the racemization. So chiral carbon compound is present mean racemic mixture form. Already I told in the previous tertiary butyl bromide is achiral. Therefore, racemic mixture is not formed. Here, now I took here one compound. What is this? Around this carbon, methyl, hydrogen, ethyl, bromine. Chiral, for example, R S configuration, S2 bromobutane. This will be a first step. Then what will form this rate determining step carbocation formed. So which carbocation? This is two carbon bonded. This is secondary carbocation, not tertiary here. Secondary carbocation form. Now, second step. This carbocation having empty p orbital perpendicular. Therefore, front side attack or maybe back side attack. Then front side attack means OH front side, back side attack means back side. So leaving group side only OH group attack mean that is called retention configuration. Leaving group opposite side OH attack mean that is called inversion configuration. Yes configuration as a reactant yes configuration, and but here opposite configuration that is R. Therefore, if it is, keep in mind, if it is 1:1 ratio R, that is called 50% of yeah, R sorry S configuration or R configuration form, then only that is called racemic mixture. In case unequal percentage forming, that is not racemic mixture. So racemic mixture generally optically inactive. If you read this notebook, each and every points are very clearly mentioned, and it is useful for the all competitive exam purpose. So you try to refer this video and also share to your friends. It is most helpful for the all types of competitive exam. Whatever the extra information required for this for other competitive exams, CET, NEET, JEE Mains level, that I will include in the next video. If you like and share this video, I mean it is reached to many students and it is helpful. And whatever the extra thing you want in this video, you just comment, then I will maximum that points I will include in the next videos. Thank you.